Okay, today I'm gonna show how to solve this type of equation using limits. So I'm gonna show how to solve it algebraically, numerically, and graphically. So I'm using my phone so it won't look as much good quality, but it should be pretty visible. So my problem is 2x to the second power plus 14x plus 20 divided by x plus 5, and the limit is x, which is -5. So first I'm going to try to solve it algebraically. So here we have the number and limit at -5. Okay, if we input the -5 directly in x in the denominator, we're going to have 0. This cannot equal 0, thus we cannot use this method. So we use this method instead. We divide the number in two terms. As you see, 2x to the second power plus 14x plus 20 was now put in two terms, which is 2x plus 4 and the other term x plus 5 divided by x plus 5. Here we can check if it's correct. We multiply the numbers and we see that 2x plus 4 multiplied by x plus 5 equals indeed 2x to the second power plus 14x plus 20. Thus, this is the right terms. Okay, since now we have two terms, we can eliminate the denominator with the numerator, since x plus 5, as shown here, is the same as here. So we can just cancel that off, which is clearly visible here. So now we only have one term, which is 2x plus 4. The only thing left now is to substitute. So we put -5, which is the limit, and we put it in the equation, which is 2x times -5 plus 4. 2x times -5 equals -10 plus 4 equals, well, typo, which equals -6. Okay, the next way we can solve this is numerically. Numerically, we have to use a table to show the number of clusters, to show the cluster of numbers. First off, we have the number and the limit. We have two methods of doing this. The short way, which is using a bit of algebraically, and the long way, which is actually using the whole number. In the long way, we have to input three numbers higher and lower than -5 and the original number. In the short way, we can just actually put the three numbers in x and the six numbers in x, and we can just have it a bit more easier. But here I'm going to explain real quick how to do it the long way. So this is the table. It's not really clearly visible here. Here I have a bigger one, which is -5. -5, here we have three numbers that are smaller than -5, which is -5.1, -5.01, and -5.001. Here we have three numbers bigger than -5. -4.999, -4.99, and -4.9. Now, the only thing we have to do is put those numbers back in the equation. In the long way, we have to put all the numbers, put it all in the second power, divide it by the denominator, and we're eventually gonna have, for the first one, which was -5.1, we're going to have a numerator 0.62 divided by -1, which in turn leads you to -6.2. This is the long way, and after you find the answer, you just put it in the back of the table, and there you have -6.2. If you want to do the short way, which is the way I most clearly did, we use a bit of algebraically to know which is the right number. We have to use the right term. We just input the numbers here as shown. Here we have another example, -5.01. I just substitute it right here in the terms, and we just multiply it plus 4 equals -6.02. So I just put it -6.02, and I did the same for 2 times -5.001 plus 4 equals -6.002. Back in the table, I have it here. The same for -4.999 plus 4 equals -5.998, which is shown here. And 2 times -4.99 plus 4 equals -5.98, which I input right here in the table. And last but not least, 2 times negative 4.9 plus 4 equals negative 5.8, which I put it here. Here, to find the answer of the limit that we use, we gotta find which is like the, another typo. We gotta find the cluster of numbers. As we see here, that numbers tend to decrease, and here they tend to increase here and tend to decrease here. And we see that right back in the middle, negative 6 is kind of like in between all of them. So this would be the cluster of all the numbers. And thus, we know negative 6 is the answer. And if we want to check in the algebraic way, we found out that negative 6 was also the answer. Yeah, that's two ways we can do it. The other way is graphically. Graphically, we just input the right term in the graphing calculator, and you see here that the x axis has 4, the y axis has 4, and the x axis has -2. And you see here they have like a little open dot. It's not so clearly visible here, but it has a little hole in it. This is -5. I put this little hole here because it means that we cannot use -5 since the equation won't work. So you have to put this every time you have to graph one of these type of equations. And those are the 3 types of way we can find the answer for the equation. You can graph it, use numerical in the table, or algebraically.